Alrighty, so quick repeat of yesterday. Second fundamental theorem of calculus, when you take the derivative of an integral, remember that these two variables here have to be different. Okay, and we looked at why it works here when we take the derivative of both sides. This looks horrific, but it really wasn't as bad as it looks. Then we also had it with the chain rule version, and then we were going to look at why that works, right? So let's go down to here. It says, now let's consider the same situation where we want to find this. So if I have, I think I was going to give you a different version is what I had decided. Maybe I decided wrong. Yeah. So if I'm going to take the integral, if I have the integral from 0 to f of t, some function, right, of v of x dx. Okay, so that's what they gave us, and we want to find the derivative. But let's just think about the first fundamental theorem of calculus. If I take the integral of, well, no, we're still using, I'm going to change this to, well, the confusing part of the other one was that it was the V's and the S's, and then we were changing them, so I was like, I am going to change this. I'm going to change this so that we just look at it once. So we're basically going to do the same thing. I'm just going to change the variables so it looks better and you don't get lost in the variables of the stuff. That's what I don't like about this. So we're going to go the integral from 0 to g of t, okay, of f of x dx. Okay. So the first fundamental theorem of calculus says that this will be equal to, now if I integrate the lowercase f and there's no prime on it, that's when it becomes the capital F, right? So f of the final, which is g of t, minus capital F of 0. Okay? So everybody with me on this? That's the first fundamental theorem of calculus, right? If I integrate this accumulation from 0 to whatever g of t is, it's the final minus the initial, and that's what our accumulation is. So then what we're doing, and it shows us right here that we want this derivative. So if I take the derivative of both sides, so again, we're going to write more than we probably would most of the time because I don't want you to get lost in the notation. So when I'm just going to put the derivative out in front of both of them, derivative of this, f of x dx equals, then I'm going to take the derivative with respect to t. Oh, shoot, sorry. On this side. So then this is going to be capital F times g of t minus f of 0. Okay? So this is what we're trying to show is working, right? So we're going to take the derivative. I'm just going to rewrite the left side. The derivative with respect to t, the integral from 0 to g of t of f of x dx equals. Now, when I take the derivative of this with respect to t, I'm going to get, what's the derivative of capital F? Lowercase f. So this is going to be f of g of t, and then by the chain rule, I also have to take the derivative of the inside, so that's going to be times g prime of t. Then f of 0 is just going to be some number, and what's the derivative of a constant? 0. So this right here is showing you why the chain rule one works. So if you're going to substitute something into here that is not just a plain old x or a plain old variable of any kind, you still substitute it in there, and then you also have to take the derivative of that part right there. Okay? This is the why, or the proof of it. What questions you got? We need to apply it a few more times, right? Work through some more, make sure we know what's going on. I do, back there, the blue one on the top of the little shelf there by the pencil thing. All right, so Did I give you? Yeah, you can flip it over on the back, right? Are you already on this second sheet of paper, first sheet of paper? This is the second one, right? Okay. I gave it to you yesterday, yes? Okay. Now let's look at A. It says to find, they give us capital F of x. We want to find f prime, which means we are going to take the derivative of both sides. Right? So if I take the derivative of the left-hand side, that's going to give me f prime of x. If I take the derivative of the integral, is this question here going to require the chain rule? No, because this is just a plain old x, right? It's just going to go right in there, and so this equals x plus 2. And that's it. Maybe. What happened to yours?
I thought I already had 9.
Well, you did have one. Actually, no. Oh, that's right. Somebody tried to tell you that on the way out, didn't they? It's okay. It's okay. Yeah, nobody's perfect. Least of all me. Does everybody else have one? Okay. So what do we think on B if I take the derivative of both sides? I'm going to kind of put it above because I can't really fit it there. So basically, I'm taking the derivative of both sides. F prime of x, what is that going to equal? Secant squared x. Is that simple? Yes? Okay. Is C exactly like A and B? No. So if we take the derivative of both sides, the derivative with respect to x of both sides, here we get f prime, capital F prime of x. It could also be lowercase x, but since they wrote it like this, that's why I'm writing it like that. So do I still substitute x into where t is? Yes, I do. So it's going to give me x squared minus 2x plus 5. Is that all I have to do? No. This is on the bottom, so I'm going to the left, which means what do I need to do with this? Make it negative, which means I'm just going to put parentheses around the whole thing and put a negative sign in the front and not have to worry about individual sign things. Okay? Everybody okay with that? Okay. So then let's look at D. I'm going to take the derivative of both sides. I wish these were spaced out better, but it is what it is. So on the left, I'm going to get capital F prime of x. Now, the 0, it's a constant. I can just ignore it. This right here is e to the x. That's what goes in everywhere I see a t, right? So this is going to give me e to the x times cosine of e to the x. Am I done? No, because this wasn't plain old x, so I have to take the derivative of that. What's the derivative of e to the x? E to the x. Now, is it acceptable to leave it just like this? Absolutely. If this was a multiple choice question, this would probably not be an answer choice, though. So although we can leave it and we should leave it, if we're done, we still need to know how to clean it up if we needed to match it with something, or if we needed to cancel things out or whatever. So this is also equal to f prime of x is equal to, all right, well, this I can't really change much, right? Like this e to the x isn't going to mess with the other ones. But what is e to the x times e to the x? Not 2e to the x. E to the x squared. Okay, so let's think about let's talk about what it is and what it's not and how else we could write that. If it was 2e to the x, I'd be adding them, right? 2e to the x. And so when I'm multiplying them, I do get e to the x squared, right? Because I'm multiplying them together. Y'all agree with that? But what's a cleaner way to write that? E to the, what's your power to a power rule? 2x is a cosine of e to the x. Okay, so so this is the correct step. But again, if it was, and it's fine to write it like that, but if it was multiple choice, it probably wouldn't look like that. It would probably look like that. Okay? And we just need to know that they're the same thing. We okay with that? Okay. So y'all do E and F. Remember to remind yourself, yes, it is the chain rule, but remind yourself of what you're taking the derivative of. Because something that sometimes people want to do is write this down and then take the derivative of what's on the inside of that, and that's not what we're doing. Since we're putting this into here, after I put that in there, then I take the derivative of that right there. That's where the negative sign of x comes from. Yes? Questions on either one of them? Okay. Okay, so we have, and actually our next lesson is a function defined as an integral, and we're going to do one of those before we even talk about what that really means. But this is a function, and it's defined as this integral right here. And it's asking us on what intervals, this is an integral, this is an interval. And probably when I say them, they might kind of sound the same. I will try to enunciate better. But so on what intervals is f decreasing? All right, so if we're talking about increasing and decreasing, what thing helps us figure out increasing and decreasing? The fun chart, yes. So I would have F, capital F, and then you can do it either capital F prime or little f. What would you rather do? Just little f? Okay. Is that what I heard? I'm not sure what I heard. It really doesn't matter. And then this is F prime. So how we've been doing it is this is F double prime, this is F prime, this is F double prime. So either way, it doesn't really matter. So fun chart, right? Looks like this. Okay, so F, capital F, is decreasing when little f, which is the derivative of that, is negative, right? So we need to find little f. Would you agree with that? And I'm going to find little f by taking the derivative of both sides over here. Okay? So the derivative of big F is little f. So little f of x is equal to, and then this just has an x here, so I'm going to substitute it in there, and I'm going to get x squared minus x minus 6. So now how do I figure out when this is negative? What do I have to do here? Well, this technically is f prime, right? So remember this, that this is f, this is like big F prime. Yeah, I got a factor. So this is the same thing as big F prime, okay? So when you're doing the fun chart, maybe a capital F might look better for you just to keep it straight in your head. I don't know, but either way is fine. But I'm going to factor, so I'm going to set it equal to 0. This is going to get me x minus 3 and x plus 2. So x equals negative 2 and 3. All right, I factored and I solved because it was a piece of cake. Now what do I do? Sign chart. So on my sign chart, negative 2 and 3. So if I substitute in a -3, this is going to be negative and negative, which makes that positive. And substitute in a 0, I'll get negative and positive, that's negative. Substitute in something else, I get positive. So what's my answer? -2 to 3. Okay? What questions you got? So the decreasing part still goes with negative. Figuring out if something's negative or positive is still a sign chart. The new part of this was knowing to take the derivative and how to take the derivative of this mess here. Okay? What questions you got? Good? Okie dokie. All right, write the equation of the line tangent to the graph of y equals 3 minus the integral of all that mess at the point where x equals -1. All right, so as soon as you see write the equation of the line tangent, what should we write down? Point and slope. I need a point and I need a slope. And my point, I know that the x value is -1. The y value comes from the original, okay? So if I go to evaluate this and I say, all right, well then that means that y equals 3 minus the integral from -1 to -1 of e to the negative t cubed dt. What is the value of that integral? Close. It's 0. And so it does exist, but it's 0 because those are different things. But if I'm going from -1 to -1, I'm not going anywhere, so I don't have a base to multiply. So this whole value here is 0, which means my y value is 3. That's literally just it. Okay? Remember, if these two limits of integration are the same, this area, because it's an area, right? The base to the change in your t is 0. So 0 times whatever that is still going to be 0, right? So that makes that super easy, even though it looks yucky. So I've got my ordered pair. So now for my slope, I have to take the derivative, right? So I'm going to take the derivative of both sides. So when I do that, it's like dy or d dx on both sides, d dx of that whole thing. So the derivative of y with respect to x. Okay, so as I take the derivative of this whole thing, the derivative of a constant is 0. Okay, so I just ignore that. But I still have this negative right there. I don't want to ignore that. Negative. All right, so then I'm going to take this x, and it just goes right into here. Yes? And so I'm going to get negative e to the negative x cubed. To find the slope, what I need is the derivative, remember this notation here, evaluated at x equals -1. Okay, so I found that. Now I need to actually evaluate it at -1. So this gives me negative e to the -1 cubed. Could you very easily get lost in negative signs here? Absolutely. So be careful and think about what you're doing. -1 cubed is what? -1. And then -1 is +1. So this is really just negative e, I don't know what that extra little thing is, negative e to the first, right? So your answer is just negative e. Okay, so it's not difficult at all. It's actually very easy, but it is very easy to mess that up with all the signs and stuff. Yes? Are we finished? No. We still have to write the equation of the line. Y equals, what's my slope? Negative e times x plus 1 plus 3. So you still can apply this little bit of new stuff with writing equations of lines and doing those intervals and whatnot. You got this, right? Okay. Beautiful. Let me give you the next page. This is actually today's lesson. That was actually the finishing of yesterday's lesson. It's just a continuation of this, though, so. We're going to be doing integrals for a long, long time. Yes, I would. Which I believe was 61. Which would make this 62, but somebody correct me if I'm absolutely wrong. Is that correct? Okay. Finally keeping up. It took me 60 pages, but I think I finally got it. Oh, we are missing 2 people. Oh, 3? Okay. Okie dokie. $62. Let me make sure that I have my keys up here so I don't do anything ridiculous. Okay, so like I said on that last one, functions defined by integrals. That's what we're looking at. This is what this is called, functions defined by integrals. And so our first example here, and you can see this g of x is defined by the integral of f of t. All right? So the graph of function f consists of a quarter circle and line segments. Let g be the function given by this function right here. Okay, so what could get confusing on here is the notation. All right? So g is equal to, so we've got g, I don't know how to do this. G is equal to capital F, g prime is equal to lowercase f, and g double prime would be equal to f prime. Because what they have given us is f. This is some sort of derivative that I'm going to integrate. So this is f, and it's got to be equal to g prime. So once I have this here, I'm going to say f is equal to g prime. Okay. Because I want you to think about, if I take the derivative of both sides here, okay, if I took the derivative of both sides like we've been doing, this will give me g prime of x equals, and then when I stick x in there, I get f of x. Do you see how that comes from there? Just taking the derivative just like we did on the other ones. The derivative of g of x is g prime of x. The derivative of this integral, I just take the x and put it in there, and I get f of x there. So you got to know what matches up. All right? Does that make sense to you? That's literally exactly what we've been doing, this pink part that I just wrote, when you take derivatives of both sides. That's why this is true right here. So when we say that we have f, that is g prime. And when we want to integrate lowercase f, we have to use capital F, whether we want to or not. When we're going the other way, we can decide how we want to do it. Okay? So everybody okay with that? So g is when I want to find g of 0 is equal to, and then we're going to put this right here. We're going to go from 0 to, well, since this was g of x now becomes 0 here, of f of t dt. Well, that's my graph of f right there. When I want to find the integral right now, we're looking at the area under the curve. What is the integral when our limits of integration are the same? 0. So this answer here is 0. Everybody okay with that? All right, so then g of -1 is equal to the integral, and I'm using this right here again, from 0 to -1 of f of t dt. So when I look at my graph, I'm going from 0 to -1. So what is the area of this triangle? 1, because it's 2 times 1 divided by 2, right? So the area is 1. Is my answer 1? It is -1. Why? I don't know. Because we're going from to the left. We're starting at 0, going to -1. So since we're going to the left, this area is now negative. Okay? It's above the x-axis, so it's a positive area, But because we're going from 0 to -1, we're going to the left, we change the sign. Yes? Okay, so you're kind of putting all this together. So then g of 2, that's going to be the integral from 0 to 2, f of t dt. So going from 0 to 2, that means I need the area of this. It tells me it's a quarter circle. What's the radius of the circle? The radius is 2 pi r squared. So the area of the circle is what? Yeah. Well, the circle itself is 4 pi, right? I know what you're trying to say. You're like ahead of me there. But the radius is 2, so the area of the entire circle is 4, right? It's a fourth of the circle. We divide that by 4, we get what? Pi. Yeah. Then the last one is g of 5. So g of 5 is going to be the integral from 0 to 5 of f of t dt. Going from here to here. All right. So I've got this part, which is pi, and then I have this. If you want to break it into, well, you can break it into a couple of things. See if you can find that area, because you can use some trapezoids here, you can use a bunch of triangles, but y'all come up with the area of this little spot here, and then we'll see how many different ways we did it. Okay. We come up with this area. What is it? 4. Okay. So this is 4. Well, just this part, yeah. So we could, like, I first cut it here, and then I could use a triangle and a trapezoid. Anybody do it that way? Probably not. I figured. Okay, good job. And I figure most of you, you're like scared away from the trapezoids, right? Okay, but then I could make a triangle here and a triangle here. Is that how most of y'all did it? And then you get 1, 1, 2. Either way, you get 4 in the end, right? It is below the x-axis. I'm going from left to right. So it would be that pi, and then I heard it, -4. And I heard some discussions about why it would be negative, and you're correct. Okay. Good job. What questions you got? Okay. See, it's fine if you don't know how to do the trapezoids for this particular one, as long as you know how to figure it out. And you were able to figure it out, and you're all good. Trapezoid, it's like a triangle, 1/2 base times height, but instead of base, it's base 1 plus base 2. You add the 2 bases. Okie dokie. Let's look at B. Find all the values of x on the open interval from -1 to 5 in which g has a relative maximum. Justify your answer. All right. What do we look at that helps us figure out maximums and minimums? The sign chart. Okay, so we've got g, g prime, and g double prime. So really, instead of the fun chart, it kind of looks like the gun chart, but I know. Eek. That's still better than the other, but I don't know. Maybe. And then you also want to keep track of g prime is actually f, and then this is capital F, and this is f, little f prime. I highly suggest on these that you actually write those things out and don't just think you're going to keep them straight in your head, because again, they're fairly simple, very easy to get all mixed up and use the wrong one, okay? All right, so we want a relative maximum. A relative maximum happens for g when g prime does what? Switches signs. In either way? No. If I have a relative maximum, see how I'm increasing and then I'm decreasing? That's when you get a relative maximum. So it has to specifically change from positive to negative. If it changes from negative to positive, then I get a relative minimum. Does that make sense? So yes, it's when it changes signs, but specifically from positive to negative. So I can even write myself, and well, I'm going to say this has when G prime goes from positive to negative. Like maybe write yourself a little note so you don't then go do it wrong. Or you can go ahead and write it out as part of your answer and say that G has, like write down what you know, a relative max when G prime. Now, did they give me the graph of G prime? What did they name the graph? F. And then we know, because of how everything's related, that it's G prime, right? So anytime you say G prime related to G, which you have to because that's its derivative, right? You should always write G prime equals F because then that relates it to your graph, right? This relates it to G, which is what we're talking about, and then this relates G prime to the graph. So has a relative max when GF changes from positive to negative. So before I even worry about where it is or whatever, I have figured out what the heck I'm looking for, so I'm going to write it down because that's part of my explanation. Then I can go look at the graph. Right? When does this change from positive to negative? At 2, right? At x equals 2. Because this right here, that is the derivative of G, that's where it changes. So then I can say, therefore, G, look, it's all one word, has a relative max at x equals 2. Because you're just getting that from the graph. Now, you could say that G has a relative max at x equals 2 because G prime equals F changes from positive to negative. Like you could say it the other way and say it all in once. But when you say it this way, you're writing down what you know before you figure out exactly where it is. Whatever makes the most sense in your brain, it doesn't matter just as long as you say all the stuff you need to say. Okay? And I kind of flip back and forth between the ways I say it, sometimes based on the way the question's asked, but my brain also just works in weird ways. So, okay, so now that was relative. Your relative maximums, that happens, and we can do this, and if we didn't have a graph, we could use a sign chart. Now we're looking for the absolute, okay? An absolute minimum on this interval. And the value of x is where it occurs. So if I'm looking for the absolute max, do you remember what I have to do? Candidates test. Very good. I need the candidates test. All right, so on the candidates test, we are going to have a little x and y chart. I know that on this chart, I have to use the endpoints of the interval. So -1 and 5 for sure. And then any other critical point, right? Where are your other critical points? Two. That's just it, right? Your critical points occur when the derivative is 0 or the endpoints of the interval. So this is 2. Now tell me, can 2 be the absolute minimum? No, because we just said it's a relative maximum, right? You can't be both. But I still have to put it on my chart because you have to do one of two things. You have to consider it. So you could write that 2 can't be the absolute minimum because it's a relative maximum. Or you could just put 2 on your chart and consider it. And to me, that's easier, right, than writing out another explanation. Just go ahead and always consider everything. That's the best advice that I have gotten in that stuff, and I would agree. Otherwise, you have to explain, so you might as well just do it. It's not that big of a deal. Okay, so then we have to find what these are. Do we know, have we already found what g of -1 is? What is it? -1. Have we already found what g of 2 is? Yes, what is it? Pi. Okay. And then have we found what g of 5 is? Yeah. Pi minus 4. Right? Okay, now, do you know exactly what pi minus 4 is? No. So we already know that this can't be our absolute minimum. Of these two, we're trying to figure out which one the absolute minimum is. Is this number here, whatever it is, going to be bigger or smaller than -1? Bigger, yeah. Smaller, but then it's negative, which makes it bigger, right? That's a little messed up to think about, but yeah. Because pi minus 4, let's say that pi was 3.25 to make it easy, all right? 3.25 minus 4 is a -0.75, which is bigger than this number, even though 0.75 is less than that, so this is greater than 1. Greater than -1, dang it. Sorry. It's bigger than this number, right? That's all we really care about. It's okay that we don't, because we're just trying to compare them, right? So then where's the absolute minimum value of g? At -1. Okay, so the absolute minimum of g is -1 at x equals -1. They're the same number, which makes it a little weird, but we have to, because it says find the absolute minimum value, that's that, and the value of x at which it occurs. Okay, this is what it is, this is where it is. This is the, y is the what, x is the where. Okay, what questions you got? Okay, I think we can get through D before the end. No, there's no questions. All right, we're going to find the x-coordinate of each point of inflection of the graph of g, and we're going to justify our answer. When does a point of inflection occur? When the concavity changes. Good, so this is a change of concavity, right? Where concavity changes from concave up to concave down. So if we look back at the chart we already made, the concavity changes, these are the concavities, it changes here. So it changes from when g prime changes from increasing to decreasing, right? If we're changing from concave up to concave down or vice versa, it's where g prime, which is what the graph we have is, goes from increasing to decreasing or vice versa. So we're increasing and then we start to decrease. So we have one right here, yes? And then we're decreasing, we keep decreasing, then we start increasing, so we have one here. Would you agree with that? That makes sense? Okay. So then we can say G has a point of inflection at x equals, what was it, x equals 0 and x equals 3. Because, okay, so if we're answering about g, we have to talk about g prime. But what do I have to put with the g prime? Equals f, okay? Because g prime equals f changes from increasing to decreasing or decreasing to increasing. So see how we're kind of literally putting everything together? It all starts to connect. What questions do you have? You good? All right. So I'm going to put those into AP Classroom also. What you have to have done by today, or really probably by Sunday, because I'm not going to even be able to look at grades until then, is the 6.1 through 6.3 in AP Classroom. Okay? Not saying to procrastinate on this, but you're going to need to get this done too. Okay.